Alright guys, so I just got my Stetsom Force Extreme directly from the factory in Brazil, here in the US. I just want to cover it in depth a little bit. So before I begin, just want to note that this is a high voltage amplifier. Yes, it's for car audio, but the setups in Brazil are a little bit different. They're not in a car, they're actually huge setups that the car tows behind them. Second, this is high voltage, meaning that they run at up to 440 volts. So you do not plug this into your 12 volt bus in your normal car and expect this to run, because it won't. So completely different architecture and design, and I want to talk about it a little bit here, and then we could dive in and just discuss it further. I have the data sheet for the IGBT that the amplifier uses it. The IGBTs here are rated for up to 600 volts and can run up to 140 amps continuously. So we're talking about 60, 70, 80,000 watts per IGBT at maximum voltage. Of course, that's not what we run the amp at, so we'll dive into the details a little bit. Looking at the manual, it's pretty straightforward. If you are interested and want to download a copy, you can go to their website. They rate the amplifier at 180,000 watts at 300 volts at 0.25 ohms with 150 amps recommended battery continuous, maximum of 600. However, if we dig in a little bit deeper, we can see that it actually goes up to 195,000 watts for short bursts. And from a technical perspective, we could actually go much higher, and I'll talk about why that is. However, these are limitations because of the components and also thermal dissipation. These, if we look at the IGBTs, thermally they could dissipate 500 watts no problem, 454 actually, and then when you add the heat sink, you increase that significantly, but still you can't expect something like this to continue running at 200,000 watts and dissipate all that heat. So let's dive into the amplifier guts. All right, so the first thing I want to talk about really quick is the 12 volt section and the high voltage section, since people get a little bit confused for some reason when they see that it's 12 volts, so they assume that it works on a normal car 12 volt bus. The 12 volt section is used to mainly run the fans on the amplifier and to run the circuitry, the control circuitry, which takes in your RCA signal and essentially just flips the IGBT gates. So the idea is it uses a low voltage bus, 12 volts, to flip the voltage on these 400 volt components. So unlike a car amplifier, normal one, which takes in a 12 volt source, has to take that 12 volt and increase it up to 140 volts, and then use the other 12 volt source to essentially output that back to the speaker output. This system works completely differently. So all these guts that you see here are dedicated to the high voltage section. So we're missing, if this was a 12 volt amplifier, we probably have like 20 extra feet to support this side of extra components that we don't have to have here, because we're getting a high voltage signal in to begin with. So about 60% of the components, 80% are not even needed. So we're looking at a completely different electronic architecture here than you're used to if you're into car audio. So these components are responsible for powering the fans and essentially just turning these gates, jiggling them basically at the appropriate frequency based on your RC input. Very simple. So if we look at what we're working with here, is we have these, I mentioned, big IGBTs that can do 600 volts a piece. They're massive if you compare it to my finger. And they'll do over 100 amps a piece. And there's 20 of them. And we have an AC signal, of course. So we have one side of the AC pulse and the other side. So essentially, we could take the output of 10 of these. That's half of your AC signal. The other 10 is the other half of the AC signal. We have 400 volt capacitors here to stabilize the current. And then we have smaller, higher frequency capacitors as well over here. Again, to stabilize all that power coming in. On the output side, we have 0 gauge output for the speaker wire. Again, this is meant to run huge installations that can actually take 200,000 watts of power. Not meant really for small single car subwoofer applications like I use it for, but it works nonetheless. And this is your input, your zero gauge input. Again, zero gauge can do 100 amps easy. It can even do up to 300 amps, but not for long because it does get pretty hot. So 300 amps at 400 volts is 120,000 watts, and you could burst it even higher than that. Resistance increases, heat increases, etc. And this is why, even though the amplifier can do a ton of power, it's technically not rated for that because the solders and the size of the inputs here are really not meant to handle the amount of current and the heat generated by the amount of current. So technically the components can do well over 200,000 watts. However, this thing seems like it'll run pretty well at 180,000 watts as rated, as long as you could cool it sufficiently. If you have any questions, let me know. I'd be happy to jump into this further, discuss it in more detail, but what you see here is pretty straightforward. Unlike a normal car amplifier, this one is so much simpler. You get high voltage in, then you jiggle the output to create an AC output. Nothing to it.